Okay, so quick, this is review from what we've done before, reciprocal identities. The only thing we haven't really done is written it this way, but you've known it, so we're just reviewing all there. Pythagorean identities. Where it comes from is what we know about our unit circle. Okay. If this were a unit circle, what would this hypotenuse right here be? 1. This is the x and this is the y. Do you guys agree? Yes or no? All right. And Pythagorean's theorem states that x squared plus y squared equals, or a squared plus b squared equals c squared. What is c in this case? 1. Does everyone agree with that? All right, I'm going to put parentheses squared plus parentheses squared equals 1. And in the parentheses, I'm going to take x and y out, and in its place put the sine and the cosine. Which one does the x represent, the cosine or the sine? Cosine. Cosine. So I'm going to put cosine in its spot. Cosine x, and y is the sine. All right, so the way we write this, it is cosine squared plus sine squared, but most of the time you're going to see it written like this. Sine squared coming first, sine squared plus cosine squared, x equals 1. Need to know this, have this memorized. Sine squared plus cosine squared equals 1. Now, does it matter if the cosine squared x comes before the sine squared x? Is addition commutative? It is commutative, so it doesn't matter, but this is typically how you will see it. Sine squared x plus cosine squared x equals 1. So they'll give you something like this and ask you to simplify, and you would say, oh, that is 1. All right, questions? Now, there are 2 others that we will need to have memorized. And you also need to worry or think about how to move these around, which we'll talk about in just a little bit. Right now, let's figure out the other 2 identities. So what I want you to do right now, if you're visual like me, you need to see what I'm talking about. Sine squared x plus cosine squared x equals 1. I want you to go through and divide each one of these by sine squared. As long as I do it to everything on both sides, is it still the same function? If there's an equal sign and I divide everything on both sides of the equation by the same thing, is it still the same function? Yeah. Yeah, as long as I do it to everything, it's consistent, it's still the same. All right, what's sine squared over sine squared? 1. Plus, what's cosine squared over sine squared? If cosine over sine is cotangent, what's cosine squared over sine squared? Cotangent squared. And, okay, tell me where's the question?
You said if cotangent is cosine squared over sine squared, what is
all right, so I'm going to repeat because I don't know what the heck I said. If cotangent is cosine over sine, yes? If cotangent is cosine over sine, and here I have cosine squared over sine squared, that's pretty much saying squaring both sides, squaring both sides. Do you see that I would get cosine squared over sine squared? Yes or no? So I could write this as cotangent squared x. Does that make sense? Better sense than whatever I said the first time. All right, equals, what is 1 over sine? 1 over sine is cosecant. If I squared both sides, I'd get 1 over sine squared on this side, and what on this side? Cosecant squared x. So that there is my second identity. 1 plus cotangent squared x equals cosecant squared x. Now, when you're working on homework tonight, it would be a good idea to have your notes out to kind of look for the identities, but over time you want to work on having them memorized because it'll speed things up for you, especially on test day. As you've known, tests can sometimes take a long time, and you don't want to spend all your time trying to remember what these look like. All right, last one. I'm still going to take the original, which was sine squared x plus cosine squared x equals 1. But this time, what do you think I'm going to divide everything by? Cosine squared. So cosine squared x, and cosine squared x. And again, as long as I do it to everything on both sides, it's still the original identity. Just looks different. All right, what does this simplify to? Sine over cosine, where's that? Sine over cosine is what? Tangent. If I square both sides, would I get sine squared over cosine squared on the right side? Which would give me what on the left side? If I squared both sides, tan squared x. So can I write sine squared over cosine squared as tan squared x? All right. Next piece, what do I have? Cosine squared over cosine squared is what? 1. Now, where's 1 over cosine? 1 over cosine is secant. If I square both sides, would this side here give me 1 over cosine squared? Yes? And what would this become? Secant squared. And there is your third identity. All right, so what do we have? Tan squared x plus 1 equals secant squared x. All right. Do you need to know all 3 of these? Yes, and you need to recognize the rearrange as well, which I'll show you in a second. But if you have these down solid in your brain can process the rearrange pretty quickly. All right, so again, you may not have it memorized right now, so have these out, get the practice tonight with your homework. You'll become better at it, and then come test day, hopefully it'll all be there and you'll be good. All right, can I move on? All right, most kids get this one down solid. How many of you feel like that when you can say and do without any real effort? Yeah? Now, if worse comes to worse and test day comes and you cannot remember these, should you at least know the tools and how to generate them? Yes? So when I give you a unit circle paper, you can just jot them down really quick. And oh no, I can't remember these. What do? We divide the original everything by sine squared. Get the second one, and then we divide everything by cosine squared. Does it matter which one you do first? It does not. All right, the order in which you write these down does not matter. Okay, questions before we move on? Yes?
Why would you divide like sine squared and like cosine squared?
Like why do we do this?
Yeah.
You don't have to do it. I was just doing it so you see where the identities are coming from. Pretty much I could have just said ignore this. Identity 1, identity 2, identity 3. You need to know these 3 Pythagorean identities. If you Google Pythagorean identities, these will pop up. I was just giving you the math tools to figure out where these 2 are coming from. They're not just like magic and like poof, here they are. This one came from Pythagorean's theorem, which is why they're called Pythagorean identities. And then these 2 were generated from just changing the way this looks by dividing and dividing. Do you need to know this? No. Is it a good tool to have in case you forget how to generate these 2? Sure. All right. Okay. First rearrange we're going to have is the first one. So I'm going to rewrite it. Sine squared plus cosine squared. I'm going to repeat that. Sine squared x plus cosine squared x equals 1. All right. I'm going to put an arrow. You may see this rearranged as sine squared x equals 1 minus cosine squared x. I want you guys to quickly look from here to here and see if it makes mathematical sense that these 2 are exactly the same.
Yeah.
Can you see what was done? Okay, anybody tell me what was done from here to here? Subtract the cosine squared to the other side, yes? Now, I'm not going to write all the possible rearranges for this particular function, but there are more than one. Instead of sine squared equals, what could I have here? I could have left cosine squared x here and have 1 minus sine squared. Would that still be equivalent? Now, tricky, this one always stumps people up. I'm going to write it in pencil and erase because I do need this space. But what would happen if I flipped this? Cosine squared x minus 1, because that does come up. Anybody know what that equals? Think about mathematically. That has a special name, or do the work over here in your head. Okay, Leonard, can you tell us how you knew that? What did you process in your head? He said negative sine squared x, which is correct. Good job. Because they're opposites. Do you guys agree that 1 minus cosine squared and cosine squared x minus 1 are opposites? Yes, so what's the opposite of sine squared? Negative sine squared. Anybody else can see it different from the way he said it? Can anybody do the math over here and see that if you move the sine squared over here, you get negative sine squared x, and if you move the 1 over here, you get cosine squared x minus 1. Can you guys see that mathematically? Yeah, however your brain processes it. The way he said, Leonard said it, oh, I just saw that these were opposites, or you kind of do the rearrange in your head and you say, oh, how do I get cosine squared x minus 1? Move this over, move that over, negative sine squared. Make sense? All right. If you have the room, leave it. Actually, I'll just write it a little smaller on top. What did we say? Negative sine squared x equals what? Cosine squared x minus 1. All right. Next one, I'm going to write the second identity. 1 plus cotangent squared x equals cosecant squared x. Now I'm going to start you off. I'm going to write this as cotangent squared x, or cotangent squared x. Can you do the rearrange either with your pencil redoing it, or can you redo it in your head? If I get this by itself, what do I end up with? Okay, cosecant squared x, what? Cosecant squared x minus 1. Now process in your head. If I had negative cotangent squared x, what would this look like? I'm going to repeat that. If this was negative cotangent squared x, what would this side look like? 1 minus cosecant squared x. Do you guys see that? Opposite business. All right. Now again, I'm not writing all the possibilities. I'm just writing some. For example, there's a lot of things. You can have 1 equals cosecant squared minus cotangent squared. There's a lot of different ways to rearrange. I'm just giving you the basics. Tangent squared x plus 1 equals secant squared x. I'm using the third one right there. I will start you off. I'm going to give you tan squared x equals. You do the rearrange on paper or in your head. If I get tan squared by itself, what does it equal? Secant squared x minus 1. If I had 1 minus secant squared x, what would it equal? Negative tangent squared. All right. So should you have these, or at least start working on programming these in your head as well? Yes? Work on the original set first. And once these are solid and done, these are a little easier to at least recognize. You may not have them memorized, but you at least recognize them because you have these down solid. Does that make sense? All right. Questions? Okay, we're going to go through and do some examples, some quick examples. Examples, we are going to simplify. No fractions in your final answer. No fractions in your final answer. So on the test as well, when you end up with something like this, 1 over cosecant x, that's the actual problem I'm giving you. But on the test, if you're doing work and you end up with this and you give me this as your answer, would I mark it wrong? Yes, because what did I just say? No fractions. So look back at your notes, or you think in your head, cosecant's the reciprocal of what? Sine. So if I have 1 over cosecant, what does that equal? Sine x. Sine x, and you are done. If you look, if you look back at your original piece up here, we have that right here in our bubble, do we not? Sine x equals 1 over cosecant. All right. So number 2, cosine x times secant x. We've done that one before, at least in Unit 3. I gave you guys actual angles here that were wonky and we didn't know how to work out. What does this equal? 1. Do you guys agree? If you don't see it, I'm going to write it out really quick. Cosine x times secant is equivalent to what? 1 over cosine x. And what happens here? 1. Are we good? Okay. Number 3. Secant squared x minus 1. Again, on this first day, you're going to be doing a lot of looking at your notes, looking at your original and seeing if you can rearrange, or since we did write the rearrange, you can go there. What does secant squared x minus 1 equal? Let's check. Where's the secant? Secant squared x minus 1 would equal what? Tangent squared. Is it one we do have down? Yes, we do. So what's secant squared x minus 1 equal? Is there really any work on some of these? There is not. There will be quite a few where there's not. All right, questions before I move on? Okay, this next one does have a little more work. Cosecant x times the square root of 1 minus cosine squared x. All right, any thoughts?
Put it under a fraction.
Put what under a fraction?
1 minus cosine squared x.
Put 1 minus cosine squared as a fraction? What do you mean?
Like in parentheses into the 1/2.
Oh, I see what you're saying. Yes, you can. I'm not going to because it's not necessary, but yes, it's okay to do. Any thoughts on what I just bubbled? Okay, can I square root them individually and say the square root of 1 is 1 and the square root of cosine squared is cosine? No? Do we have anything for 1 minus cosine squared looking here or at your rearrange? Is 1 minus cosine squared sine squared? So cosecant x times the square root of sine squared x, and what's the square root of sine squared? Go ahead, Yvette, ask me your question. How did I get from here to here? Yeah. I just want, but you can go down just to your rearrange. It's right here. Sine squared x equals 1 minus cosine squared x. And that is coming from this one right here. If I get 1 and I take cosine squared x to the other side, I'm left with sine squared x by itself. Do you guys see that? All right, and then what's the square root of sine squared? And what's cosecant times sine? 1, because cosecant's the same as 1 over sine x. That step you don't have to show. I'm just showing you in case anybody is not quite sure. All right, questions? Am I going too fast? I'm going to write this next one and just let you guys try it. 1 minus sine squared x over cosecant squared x minus 1. All right, so one of you try that one. Look at this. Looks like this might be in the rearrange section. Well, the 1 minus sine squared is not, we didn't write it in our rearrange section, but did we talk about it in our rearrange section?
Yeah.
Yes, we did. Okay, so looking at your rearrange section right here, I have 1 minus cosine squared, but not 1 minus sine squared. Could I fix this to be 1 minus sine squared? Yeah? Okay, think about it and write it down and keep going. So again, we didn't write them all, but we have the ability to rearrange and work it out. Did anybody get it? What was that? Okay, can you at least tell me, can you guys tell me what you have for 1 minus sine squared? Cosine squared x, and what you guys get for cosecant squared x minus 1? Okay, did anybody get at least that far? And now, can you go further? Yes, you can. Why? Because cotangent has cosine and sine in it. So can I maybe do some rewriting and reciprocaling and reducing? Yes. The which one? Let's see. 1 minus sine squared. If I have 1 and I subtract the sine squared, would it be positive or negative? Okay, so it would be negative if it was sine squared minus the 1, because then the cosine squared would come over negative. Does that make sense? Okay, good. I'm glad you're asking these questions, though. All right, so what should I do with the cotangent squared? Rewrite it. So if you have any of these reciprocal functions or tangent functions even, you can rewrite and try to see if you can reduce. Okay, cosine squared x over, I would write cotangent not with tangent but with cosine and sine. Sine over cosine or cosine over sine? Okay, now where did I mess up? I forgot my squared. It is not just cotangent, it's cotangent squared, which means it's cosine squared over sine squared. And we've learned from before that when dividing fractions, you multiply by the reciprocal cosine squared x times sine squared x over cosine squared x. Do you guys see how I got that? Cosine squared x is the top, and I just put it over 1. Cosine squared x over sine squared x, I reciprocaled, and it's here. And what ends up reducing? The cosine squared x, and what's my final answer? Sine squared x. Questions? Yes?
How did you get the cosine squared x on the top?
Can anybody answer that? She asked, how did we get the cosine squared x up here at the top? Anyone? Come on. Yes, Athena.
When you look at the equation that she gave us, you kind of we minus the sine x over, so it is 1 minus sine squared x, and then so that's equal to cosine squared x.
Do you see that? Good. So she said it. I wrote it as she was saying it. Thank you, Athena. She said when you work with what was given to you and you subtract this over, you get 1 minus sine squared, and you're left with cosine squared. Good. All right. Any other questions before we move on? Okay. Number 6. Cotangent x times sine x all over cosine x. All right, thoughts? You're given this problem on the test. What do you do? No, we don't give up. Okay, good. Now, Key said we can rewrite the cotangent x. So should we change everything to sine and cosine when we can and we're trying to simplify? Yes. So this is already sine, this is already cosine. I can't change that, but cotangent we can change, and it's not squared. We change to what over what? Good job. Cosine x over sine x times sine x over 1. Good job. And then all over cosine x. I'm going to let you finish from there. Okay, so the only thing we changed was this. Key said, hey, change the cotangent, which we listened to, and we did. And that's as far as I've taken you. What ends up happening? It becomes 1 how? Sine x, and you're left with cosine x over cosine x, which reduces to 1. Got it? Yes? No? Got it. Oh, it was a got it sign. All right. Number 7. Sine squared 28 degrees plus cosine squared 28 degrees minus 1. A lot easier than you think, and it's definitely on the test. What throws people off right off? The degrees. First off, what the heck? Second, are these unit circle numbers that we can work with? No. All right, so I'm going to focus right in here, and I'm going to cover the minus 1. Can anybody tell me what you know about sine squared 28 degrees plus cosine squared 28 degrees? It equals what? 1. Does it matter what the degree values are? No, as long as they are the same. So if this was 28 and this was 25, would it be 1? No. No, they have to be exactly the same. Like 28 and 28, or 75 and 75, or even 45 and 45. It doesn't matter as long as they are the same. Sine squared x plus cosine squared x is going to equal 1. So I have 1 minus 1, which is 0. How did I get what? This red part here?
Yeah.
Can anybody explain that? I heard people mumble. What is it?
Because the thing is sine squared x plus cosine squared x equals 1.
That's the identity.
Combine those, it's
Right.
just 1 and then minus 1.
And if it equals 1 because these are both x's. If this was sine squared x plus cosine squared y, would it work? No. The reason these all work is because these have the same variables, squared x, squared x. Do you see that? Now, so if I change that x to 2 angles, and it's like, what did we have? 28 and 28, is it still 1? Yes, because x is the same. You've got it? So that's what I was saying. If this was 28 and this was 25, could we say it's 1? We could not. We could not say it's 1 if these 2 angles were not the same. The only reason we're allowed to do this is because, 1, it's the identity, and the 2 angles are the same. Got it? Yeah. Okay. Number 8. All right, so try this one on your own. Sine squared 35 degrees plus cosine squared. Actually, I'm going to change that. If you're writing in ink, just keep writing. Sine squared 35 degrees plus 52 plus cosine squared 35 degrees. All right. Now, is addition commutative? So does it matter that I split it and put it out of order? No. Do I still have a sine squared plus cosine squared? Are they still the exact same angle? Yes. So what do I get here? 1, and it's 1 plus what? 52, which equals 53. Questions? Okay, number 9. Cosine of 40 degrees over sine of 40 degrees times tangent of 40 degrees.
1.
Okay. Now, I heard an answer right off. Before we discuss his answer, first off, are all these angles the same? So since they're all the same, can I reduce and do everything else as if they were x's? Yes. All right. I'm going to have you think about his 1 that he shouted out and how in the heck did he get it so fast. Think about it. See if you can do it in your head. I do want to see some work, but see if you can understand it. Anyone want to explain it other than Austin? How he got 1? You've got it?
Yeah.
Tell us.
Okay, so you're going to have to rewrite tangent of 40, and tangent is sine over cosine.
Okay, so let me write that. She said rewrite the tan of 40, and tangent is sine over cosine, and they're both 40 and 40, and this stays cosine 40 over sine 40, and what happened there? Cross reduce, and is it gone and gone, so you're left with 1? Good job. Austin, how you did it, or did you do it a little different?
Same thing.
Same thing. All right. Did anybody change cosine sine to cotangent and then say cotangent and tangent? Now, this is a good way because we typically want to change tangents and cotangents to sine and cosine. Awesome. Questions? Okay. What? Test? Oh, I know we're not going to have time. Don't be mad at me. But I finished them, and I even graded some at the game last night. But I couldn't watch the game because I was a ticket taker, so it's not like I was ticket taking. I wasn't like watching the game, grading papers. That's just mean. All right. Cotangent squared x 1 minus cosecant squared x, and I'll leave it there. Okay, work, work, work. I will tell you that they were good scores. I mean, not scores, but as I graded, they were looking good. All right, get to work, get to work. Anybody have it? -1 is correct. So keep working. If you haven't gotten there yet, keep working. See if you can get the -1. Can I give you one piece of advice? Focus here first before you start changing everything to sine and cosine. Like, kids will say like, oh, sine, cosine. Yes, you could do that. But if that looks like it's a rearrange, focus there first. Do we have anything for 1 minus cosecant squared? Oh, we do. And this one we've talked about. It's right here. What's 1 minus cosecant squared? Does everybody see that? It's negative cotangent, so what do I end up with? Cotangent squared x over negative cotangent squared x equals -1. Not the only way to do it, but it is pretty easy. Does that make sense? Questions? Yes. Which way is the other way? Is that what you're asking? Like, you want me to show you the other way, or do you have a thought of how you would do it? Cosine squared x over sine squared x. And then 1 minus cosecant is 1 over sine squared x. I wouldn't, oh, did you change it to negative cotangent? Yeah. Okay, to negative cotangent squared x over 1. But I'm going to change this to cosine squared x over sine squared x over negative cotangent is negative what over what? Cosine squared x over sine squared x, and then you'd multiply by the reciprocal, and when you do that, what ends up happening? Is it still -1? Yes.